When most people think about a modern airplane, they usually picture massive jet engines, lightweight composite wings, or incredibly advanced electronics. But there is one component that receives far less attention, even though it ultimately determines whether an engine can cross oceans for thousands of hours or fail just minutes after takeoff. Surprisingly, that component isn't a revolutionary computer system or a new turbine design. It's the metal itself. More specifically, it's a family of materials so advanced that only a handful of companies around the world have mastered their large-scale production. And there's a good reason for that. Without these materials, modern aviation, from commercial airliners to military fighter jets and even spacecraft, would look completely different. That's exactly why what appeared to be an ordinary business announcement recently caught the attention of the aerospace industry. A company founded nearly 250 years ago decided to invest $50 million to build a new facility in Alabama. At first glance, it sounds like another economic development story. A new manufacturing plant, a few dozen jobs, and a package of state incentives. But once you understand what will actually be produced inside that facility, the story becomes much bigger. What is coming to Alabama isn't just another factory. It's a facility dedicated to producing one of the most critical materials in modern engineering. And that may be why industry experts see this investment very differently from everyone else. To understand why, we first need to answer a question that almost never comes up when people talk about airplanes. What truly limits the performance of a jet engine? Many assume it's horsepower, fuel efficiency, or aerodynamics. In reality, one of the greatest challenges has always been heat. The hotter a turbine can safely operate, the more efficient it becomes. In simple terms, higher temperatures allow an engine to extract more energy from every drop of fuel, producing greater thrust while consuming less. That sounds like an obvious solution. Just make the engine hotter. The problem is that ordinary materials simply can't survive those conditions. Steel, for example, is incredibly strong and is used throughout virtually every industry. But under extreme temperatures for extended periods, it gradually loses the mechanical properties that make it so valuable. Aluminum, famous for being lightweight, melts far too easily for the hottest sections of an aircraft engine. Even titanium, known for its exceptional strength-to-weight ratio, reaches its limits when exposed to the most demanding temperatures inside modern turbine engines. Inside today's jet engines, some components operate in environments exceeding 1,000 degrees Celsius. In the most advanced engines, the hot gases can reach temperatures even higher than the melting point of many conventional metals. At first, that seems impossible. How can a metal component survive in temperatures hotter than the point where it would normally melt? The answer lies in decades of breakthroughs in materials science, highly sophisticated manufacturing processes, and advanced cooling technologies. But it all begins with a special class of materials known as superalloys. Contrary to what many people believe, a superalloy isn't simply a stronger metal. It's the result of carefully engineered combinations of multiple chemical elements, each selected to provide specific properties that would never exist in a pure metal. Most aerospace superalloys are based primarily on nickel, while others incorporate significant amounts of cobalt, along with carefully controlled additions of chromium, aluminum, tungsten, molybdenum, tantalum, niobium, and several other specialized elements. Every one of these ingredients serves a purpose, improving resistance to heat, oxidation, corrosion, mechanical stress, and long-term fatigue. The result is a material capable of operating continuously in environments that would quickly destroy conventional alloys. These superalloys represent one of the greatest achievements in modern engineering. Without them, commercial aviation as we know it would likely never have existed. A flight lasting 10 or 12 hours requires engines capable of running continuously under enormous pressure, incredible rotational speeds, and extreme temperatures while maintaining uncompromising safety standards. The same challenge exists in power generation turbines, spacecraft propulsion systems, and military aircraft. In every one of these applications, the failure of a single component can lead to catastrophic consequences and losses worth millions of dollars. That's why every part manufactured for these industries is subjected to some of the strictest quality standards in the world. This is where another little-known fact comes into play. Producing a superalloy isn't simply a matter of melting different metals together. Purity is absolutely critical. Microscopic impurities, far too small to be seen with the naked eye, can dramatically reduce the performance and reliability of a component that will eventually operate inside a jet engine. For that reason, many of these alloys are produced using vacuum melting processes. By removing unwanted gases and contaminants during production, manufacturers create a much more uniform, stable, and reliable material. Achieving this requires extraordinarily sophisticated equipment, specialized engineering knowledge, and decades of manufacturing experience. It's not the kind of technology a company can decide to build overnight. Perhaps that's why so few companies compete in this market. While thousands of manufacturers around the world produce steel, aluminum, or common industrial alloys, only a relatively small number possess the technical capabilities required to supply materials for commercial aircraft engines, industrial gas turbines, and advanced aerospace applications. Once a company earns a place in this highly specialized industry, it often develops long-term relationships with some of the world's largest aerospace manufacturers. If we look inside the engines powering today's commercial aircraft, we quickly realize that nearly all of them depend on these advanced materials. Companies such as GE Aerospace, Pratt & Whitney, and Rolls-Royce continue developing more efficient engines largely because materials science keeps pushing the limits of what is possible. This isn't simply about generating more power. It's about improving fuel efficiency, lowering emissions, extending engine life, and increasing operational reliability. In many ways, the remarkable evolution of aviation over the past several decades has been driven as much by advances in metallurgy as by advances in engine design itself. The importance of these materials extends far beyond airports. Industrial gas turbines that generate electricity operate under similarly extreme conditions, often running continuously for years. Military aircraft demand exceptional performance in the harshest environments imaginable. Rocket engines face enormous thermal stresses during launch and re-entry. Across every one of these industries, advanced superalloys play a critical role. They rarely make headlines, and most people will never hear their names, yet they remain among the most important materials behind modern technology. That may explain why investments in this industry attract so much attention from experts. When a company announces a new automobile assembly plant, everyone immediately understands what's being built. But when a manufacturer announces a new facility dedicated to producing vacuum-melted aerospace superalloys, the story often flies under the radar. To aerospace engineers and industry analysts, however, such an announcement signals something much more significant. It represents an expansion of production capacity within one of the world's most strategic and technologically demanding manufacturing sectors. This is where Alabama enters the picture. Over the past several years, the state has quietly built an increasingly strong reputation in advanced manufacturing, defense, and aerospace. New factories, engineering centers, billion-dollar investments, and globally recognized companies have transformed Alabama into far more than a traditional southern manufacturing state. Once known primarily for agriculture and automotive production, Alabama has steadily attracted high-value industries requiring advanced engineering, specialized talent, and sophisticated supply chains. And now, another major player has decided to become part of that growing ecosystem. The company behind this latest investment is Doncasters. Although relatively unknown outside industrial circles, the company occupies a strategic position within an industry that almost everyone depends on without ever realizing it. Its products don't appear in television commercials. Passengers boarding an airplane rarely know its name. Yet its materials are found where reliability matters most, inside the machines that keep the modern world moving. To understand why this investment matters, we first need to understand the company behind it. Doncasters is not a startup chasing the latest trend, nor is it a manufacturer trying to break into the aerospace market. It is one of the oldest industrial companies still operating today. Its origins trace back to 1778 in Sheffield, England, a city that would eventually become world famous for metallurgy and steel production. At the time, the Industrial Revolution was only beginning to reshape Europe. Steam engines were transforming transportation, factories were replacing traditional workshops, and entirely new manufacturing techniques were emerging. Over the next 2.5 centuries, Doncasters would witness the birth of railroads, automobiles, commercial aviation, jet propulsion, the space age, and the digital era. Throughout all of those transformations, one thing remained constant: the company's expertise in producing highly engineered metal products for industries where failure simply isn't an option. Today, Doncaster's operates advanced manufacturing facilities across North America, Europe, and Asia, serving customers in some of the world's most demanding industries. While the average traveler may never recognize the company's name, many of the world's leading aerospace manufacturers are familiar with its products. The company specializes in precision castings and advanced superalloys used in aircraft engines, industrial gas turbines, defense systems, and other applications where extreme temperatures and mechanical stress are part of everyday operation. These aren't products that compete on price alone. They compete on consistency, reliability, and engineering precision measured down to microscopic levels. One of Doncaster's greatest strengths is its ability to combine advanced metallurgy with sophisticated manufacturing processes. Producing an aerospace-grade alloy is only the first step. Those materials must then be transformed into components with incredibly complex geometries, while maintaining strict quality standards throughout every stage of production. Even the smallest defect can shorten the life of a turbine blade or reduce the efficiency of an engine operating thousands of feet above the ground. That's why aerospace manufacturers invest heavily in suppliers capable of delivering exceptional quality every single time. As global demand for commercial aviation continues to recover and defense spending increases across many countries, manufacturers throughout the aerospace supply chain are facing growing pressure to expand production. Airlines around the world continue placing orders for new aircraft. Governments are investing in next-generation military programs, and engine manufacturers are working to increase production while improving efficiency and reducing emissions. Every one of these trends places additional demand on companies producing the specialized materials required to build those engines. For Doncaster's, expanding production wasn't simply an opportunity, it was becoming a necessity. The company already had a successful presence in Alabama. Its precision casting facility in Oxford had experienced multiple expansions over recent years, demonstrating that the state could provide both the skilled workforce and the business environment needed for highly specialized manufacturing. Rather than starting from scratch in an unfamiliar region, Doncaster's already understood what Alabama had to offer. It knew the workforce, it knew the local institutions, it knew the state's manufacturing culture. Most importantly, it had already proven that its operations could grow successfully there. Still, the company wasn't limited to Alabama. According to the official announcement, Doncaster's evaluated locations outside the state before making its final decision. That detail is more significant than it might first appear. Large industrial investments rarely happen by accident. Companies analyze transportation networks, energy infrastructure, workforce availability, taxes, operating costs, regulatory environments, and long-term growth potential before selecting a site. When a manufacturer planning a $50 million investment has multiple options available, every advantage matters. Ultimately, Auburn emerged as the winning location. The project includes a capital investment of approximately $50 million and is expected to create around 70 high-paying jobs within its first 3 years of operation. Those positions will offer an average hourly wage of more than $30, reflecting the specialized nature of the work being performed. These aren't typical manufacturing jobs focused on mass production. They require technical expertise, strict quality control, and employees capable of working with some of the most advanced metallurgical processes in modern industry. But perhaps the most interesting part of the announcement isn't the number of jobs or even the size of the investment. It's what the new facility will actually produce. According to Doncaster's, the Auburn plant will specialize in manufacturing high-performance vacuum master melt superalloys. While that phrase may sound highly technical, it describes one of the most critical steps in producing aerospace-grade materials. Vacuum melting allows engineers to eliminate unwanted gases and impurities that would otherwise compromise the performance of the alloy. The result is an exceptionally pure material, capable of meeting the demanding standards required for aircraft engines and industrial gas turbines. Producing these master alloys is not simply another stage of manufacturing. It forms the foundation for everything that comes afterward. The chemical composition must be controlled with extraordinary precision. Temperatures must remain stable throughout the melting process. Every batch must meet exact specifications before it can move on to the next stage of production. In industries where a microscopic defect can eventually become a catastrophic failure, consistency is every bit as important as innovation. This also explains why Doncaster's new investment represents much more than additional manufacturing capacity. It expands one of the earliest and most technically demanding stages of the aerospace material supply chain. Every successful batch of superalloy produced at the facility may eventually become part of turbine blades, combustion components, or other critical parts operating inside some of the world's most advanced engines. Long before passengers board an airplane, the materials making that flight possible begin their journey in facilities like this one. The decision to build in Auburn was also supported by a coordinated partnership between state and local leaders. Alabama's economic development strategy has increasingly focused on attracting advanced manufacturing projects by combining financial incentives with workforce development. Through the state's Job Act program, qualifying projects can receive incentives tied to job creation and long-term investment. At the same time, AIDT, Alabama's nationally recognized workforce training organization, helps companies recruit and prepare employees with the specialized skills required for modern manufacturing. Instead of leaving companies to solve labor challenges on their own, the state actively participates in building the workforce needed for these industries. Local leaders also played a significant role. The city of Auburn provided the property where the new facility will be built, along with a package of tax abatements designed to encourage long-term investment. From the city's perspective, attracting a company like Doncaster's isn't simply about creating dozens of jobs today. It's about strengthening Auburn's position within an expanding aerospace and advanced manufacturing ecosystem that could attract additional suppliers and future investments for years to come. Doncaster's leadership made it clear that the company's decision was based on more than financial incentives alone. Chief Operating Officer Jason Mays described the partnership between the state and the city as a major factor in making Auburn the preferred location for the company's long-term expansion plans. That statement reinforces an important reality in modern economic development. Incentives may help open the door, but companies investing tens of millions of dollars also look for stability, skilled workers, supportive local governments, and confidence that they can continue growing for decades. Alabama's leaders see this investment through a similar lens. Governor Kay Ivey described Doncaster's as a company that already understands what Alabama's workforce can accomplish because it has experienced that success firsthand at its Oxford operation. Commerce Secretary Ellen McNair emphasized that expansion projects from existing companies often carry even greater significance than attracting completely new businesses. When a company already operating in a state chooses to invest again instead of relocating elsewhere, it serves as a powerful vote of confidence in the business environment. Yet perhaps the most fascinating aspect of this story has nothing to do with one company or one factory. Instead, it raises a much bigger question. Why are so many aerospace manufacturers, defense contractors, and advanced engineering companies choosing Alabama in the first place? Doncaster's is clearly not an isolated case. Over the past 2 decades, the state has assembled an impressive network of aerospace companies, research institutions, military facilities, and highly specialized manufacturers that increasingly reinforce one another. In many ways, this new investment represents another piece of a much larger puzzle. If someone had predicted 30 years ago that Alabama would become one of America's fastest-growing aerospace manufacturing hubs, many people would have been skeptical. The state had already built a strong reputation in automotive manufacturing, attracting companies such as Mercedes-Benz, Honda, Hyundai, and later Mazda-Toyota. But aerospace is an entirely different industry. It demands highly specialized engineering, advanced materials, precision manufacturing, strict quality standards, and a workforce capable of operating at the highest technical level. Building that kind of ecosystem doesn't happen overnight. It requires decades of investment, strategic planning, and perhaps most importantly, a growing network of companies that reinforce one another. Today, that's exactly what Alabama has been quietly creating. One of the biggest examples is Airbus. In Mobile, the European aerospace giant operates its US commercial aircraft assembly facility, where Airbus aircraft are built for customers across North America. Every airplane assembled there depends on thousands of suppliers spread across the aerospace industry. Some produce electronics, others manufacture structural components, specialized fasteners, composite materials, or advanced alloys. A modern commercial aircraft contains millions of individual parts, and every one of them begins somewhere within an enormous global supply chain. Companies like Doncaster's represent one of the earliest and most critical links in that chain, because without advanced materials, many of those components simply couldn't exist. The same pattern appears elsewhere across the state. Huntsville has become internationally recognized as one of America's leading centers for aerospace research and defense technology. NASA's Marshall Space Flight Center has played a central role in American space exploration for decades, contributing to the Saturn V rocket, the Space Shuttle program, the International Space Station, and now the Artemis missions that aim to return humans to the moon. Alongside NASA, companies such as Boeing, Lockheed Martin, Northrop Grumman, Blue Origin, and numerous defense contractors continue expanding engineering and manufacturing operations throughout the region. Together, they create an environment where advanced manufacturing isn't the exception, it's the standard. This concentration of expertise produces an effect that economists often describe as an industrial cluster. Instead of operating independently, companies benefit from being located near one another. Suppliers can deliver materials more efficiently. Universities adapt their engineering programs to industry needs. Skilled workers gain opportunities without leaving the region. Research institutions collaborate with manufacturers. New companies are attracted because the talent, infrastructure, and customer base already exist. Over time, the entire ecosystem becomes stronger than the sum of its individual parts. That may be one of the biggest reasons why Doncasters chose to expand in Alabama instead of moving elsewhere. A manufacturer producing aerospace-grade superalloys doesn't operate in isolation. Its customers, suppliers, transportation networks, workforce, and research partners all influence long-term success. By locating in a state where aerospace activity continues to expand, the company positions itself within an environment likely to generate additional opportunities for decades to come. Another factor is Alabama's long-term approach to workforce development. Advanced manufacturing depends on people every bit as much as machines. Modern facilities are filled with automation, robotics, computerized quality systems, and sophisticated production equipment, but none of those technologies eliminate the need for highly trained employees. In many cases, they increase it. Technicians, metallurgists, engineers, maintenance specialists, quality inspectors, and production supervisors all play critical roles in ensuring that every component meets demanding aerospace standards. Through partnerships with community colleges, universities, and organizations such as AIDT, Alabama has invested heavily in preparing workers for exactly these kinds of careers. The economic impact of projects like Doncasters also extends far beyond the factory itself. While headlines often focus on the number of direct jobs created, those positions represent only part of the picture. High-value manufacturing generates demand for local suppliers, transportation companies, engineering firms, equipment maintenance providers, construction contractors, logistics specialists, and countless supporting businesses. Employees spend their income within local communities, supporting restaurants, retailers, housing markets, and service industries. Universities gain opportunities for research partnerships. Students find attractive career paths without leaving the state. Over time, a single advanced manufacturing facility can influence an entire regional economy. There's also an important strategic dimension to this investment. Around the world, governments and manufacturers have become increasingly aware of the importance of resilient supply chains. Recent global disruptions exposed how dependent many industries had become on distant suppliers and limited production capacity. Aerospace companies have responded by strengthening domestic manufacturing capabilities wherever possible. Expanding production within the United States not only improves supply chain resilience, but also provides greater flexibility as demand continues to grow. Facilities like Doncaster's new Auburn operation contribute directly to that objective by increasing the country's ability to produce critical aerospace materials. Looking ahead, demand for advanced superalloys is unlikely to disappear anytime soon. Commercial aviation continues pursuing more fuel-efficient aircraft. Defense programs require increasingly capable propulsion systems. Space exploration is entering a new era driven by both government agencies and private companies. Industrial gas turbines remain essential to energy production in many parts of the world. Every one of these industries depends on materials capable of surviving conditions that push engineering to its limits. As technologies evolve, the need for even better alloys will likely increase rather than decline. That reality makes investments in materials science especially significant. Unlike consumer technologies that change every few years, advances in metallurgy often influence entire industries for decades. A new alloy capable of operating at slightly higher temperatures can improve engine efficiency, reduce fuel consumption, lower emissions, and extend maintenance intervals across thousands of aircraft. Small improvements at the material level can ultimately reshape transportation, energy production, and aerospace engineering on a global scale. When viewed from that perspective, Doncaster's new facility represents much more than another manufacturing project. It reflects confidence in the future of advanced manufacturing, confidence in Alabama's workforce, and confidence in the state's growing role within one of the world's most technologically demanding industries. The $50 million investment may seem modest compared to billion-dollar megaprojects that often dominate headlines, but its strategic importance extends far beyond its price tag. Sometimes the most valuable investments aren't the largest ones. They're the ones that strengthen the foundations upon which entire industries are built. And perhaps that's the biggest lesson hidden inside this story. Most people will never visit the Auburn facility. They will never see molten nickel alloys being processed under carefully controlled vacuum conditions. They may never hear the name Doncasters again. Yet many of them will eventually board an airplane powered by engines that depend on technologies made possible by companies like this. Behind every successful flight lies an enormous network of engineers, scientists, manufacturers, and suppliers whose work remains almost completely invisible to the public. So the next time you hear about a new manufacturing plant opening somewhere, it may be worth asking a different question. Not how much money was invested, not how many jobs were announced, but what exactly will that factory produce? In this case, the answer reveals far more than another economic development story. It reveals how one of the world's oldest engineering companies is helping shape the future of aerospace from the heart of Alabama. While most people see another factory, the aerospace industry sees something far more important: an expansion in the production of materials that make modern flight possible. And as Alabama continues attracting companies operating at the highest levels of engineering and manufacturing, investments like this suggest that the state's role in the future of aerospace is only becoming stronger.